Well, this is Jeff Erdman, E.D.S. Inc. Shandon, and I welcome you to another episode. We're continuing on our work on the fan for the dust collection system that we're going to be building here. And so we've got that in our mill right now. What I'm planning on doing tonight is basically cutting the circumference of the disc that's going to make up the fan. And when we complete that, then we'll move on to the next phase of making some of the inner features and the mounts for the fins. And so we'll try to get that accomplished. Not the whole thing, but a partial tonight. This video might take in a couple of different nights' work, and we'll go from there. One of the other things that I wanted to show you is we have some new items in the shop. When I love auctions, as you all know, and my nephew Ian has been wanting a small lathe, and so I found a south bin for him at auction. And he got a decent price for it. It's in pretty good shape, and it came with a couple of drawers of tooling, so that's going to work out great for him. So I thought maybe I'd just take you on over and we'll show you the south bin that I got for my nephew. So a little bit of a picture for you here. So it has a little chip pan here made out of aluminum. This is the old tool holder. It's not the new device that we normally like the quick change. It's relatively small, 6-inch chuck on it, and but it'll cut about 30 inches between center. It's got a 48-inch bed on it, and it runs just fine. We've did a little bit of cutting here with some of the tooling that was in it when I got it. And all these drawers are just filled with all sorts of tooling, so that's really nice as well. So I think Ian's going to be tickled pink with this. It'll fit in his workspace. He's got just a small space to do the work in, so this is going to work good for him. So that's what we got here for Ian. Our camera's low on batteries, and I've got the other ones charging, so we'll see how far we get. Well, we're going to have to do something different because this is slipping and it's cutting it out around. So I'm looking down the center of my hole, and I'm off 1/8 of an inch, and I can see I'm not following my line. So I'm going to have to reassess how I'm going to hold this down and keep it still. I might recenter this into this bottom plate and put a dowel here so it can't shift on the the plate that I'm on, and I may drill and tap this plate and put some clamps on that are a little bit more permanent, that I don't have to pull on and off. Once I moved that clamp, then it started pulling this whole thing over. So this is a fail tonight, and we'll reset it and take it up again on another night, I think. So I think the idea that I'm going to do here is, because I've got a nice hole cut down through the center of this one, that I'll just go ahead and put a dowel in here to hold it in the center, and then plus the clamping on the plate, and that should give me what I need. But this was a total fail. This bit is just pulling this thing right into it, and well, you can see how far off the line I am already. So I'm going to be taking about that much material. I'm taking more than that off this thing. So this hasn't damaged the part, but I need to make sure that I have a good solid hold down so that this thing won't happen any further. So that's a cut for tonight. We'll reset this thing and give it another try another evening. Okay, so our last attempt at cutting this circle was a failure. We got movement in the plate as the cutter. There was a couple of things that I did wrong. Number one, my cutter wasn't overly sharp. This is a brand new cutter. It's very sharp, and it'll do a lot better job. The other issue was that my clamping was not correct. I better make sure my other camera's on. There we go. Also, my clamping was not correct. So now I've got these clamp downs bolted to I've got a piece of it's about one inch thick aluminum here. It's an aluminum plate. I drilled and tapped it so that I could put my brackets down into it and hold this part down. Now this part can't move as the bit is cutting into it. I also took and we have the I put a pin in the center of it, so it can't be moved off that center. It goes all the way down through into this plate here, and so it's keyed in, so it can't move at all. It could spin if these clamps were not tight, but it cannot move the block as I'm cutting into it. So we feel that we have it sufficiently tied down currently to make some cuts on this material. So let's go ahead and let's get to cutting. We want to cut all the way through this and get this thing pretty much ready for welding. Then we'll have to make our flaps and what have you. We've got a lot to do. So let's go ahead and we probably won't tape everything. We'll show you a few cuts. We'll move on to our next process and show you what's happening on the next process. So let's go ahead and we'll get ourselves moving. made a 360-degree cut. I'm going to vacuum up the aluminum and we'll go back to our other cut. There's no sense you watching all this process. This is just a duplication until I get all the way through this metal. So we'll bring you back on our next setup. Okay, we're ready to make our final pass. Now the trick is how do I hold this down as I make this cut and I cut away my hold downs. So what I'm going to do is I'm going to cut past these two hold downs, and then I'm going to reset. And what I've got this bar that we will put across here and to clamp this down and hold this side. The two sides over here will continue to hold down until I pass these cuts. So I'm not worried about things moving from this side. Just the leverage over here as I'm cutting across here might move something. So, and I don't want the parts that are currently in here to be chattering against the bit as I'm going through. So that's my theory. That's the way we're going to approach it. It's kind of like one of those things where you pass or fail. So we'll see how this develops. So we'll go ahead and get going with our cuts. Take it right up to this hold down, and then I'm going to put my clamp across to hold both plates. And then I'll come back to you. I'm afraid if I cut any further here, because this doesn't go all the way through, that we'll end up getting movement here that I don't want. So we're going to go ahead and make the changes now. Okay, so this is the clamping I have on it. This is into the plate below the part that I'm cutting out, that I'm using as kind of a, well, it's just a table for me to work with. I put two parallels underneath this bar that are being forced down on top of this, and they have a wide area of force. So they'll be they'll keep it against that table, and it overlaps onto this cutoff piece here. So I'm hoping that it's not going to allow this cutoff piece, as I come off the end, to fall into the cut. And this bracket over on this side will hold it all the way down until I get this cut complete 100%. So I'm pretty sure that this is going to hold just fine. It's not going to move, and we'll be able to complete this cut and get this completely cut out. And then we'll drill some holes in here so that we can hold this down a little bit closer to it. These clamps were out of the way, backed out because of the fact that I'm using a square plate and I had square material, so I had to have those backed out. So at any rate, we should be able to finish this circumference cut, and then without anything moving. And the worst that can happen to this part is it'll spin, because this is keyed into the table, the center of the table. So the very worst is this will spin, but it'll create some chatter, damage the edge, could damage my bit. Doubtful, but it could. And we don't want that to happen. I don't want these sandwiching into the bit as I'm cutting through. So hopefully we've taken everything into account, and we'll be able to finish this without any mishaps. So let's go ahead and finish our cut. we are. Made our cut. So this hole down did a nice job. Nothing moved. And after we cut loose these two brackets, still no movement. And so we were able to complete the cut without mishap. So now what we're going to do, we're going to set up our cutter for the next process. And basically what we're going to be doing is trimming this face down about a 1/4 of an inch. And then we'll start making our slots for our, well actually we're going to hollow this out even more, each one of these out a little bit more. So we'll be using this tool to come in, make passes and come out, and we'll leave a little leg sticking up that we'll put our fin into, that we'll route into or not route into, but cut into. I'm using woodworking terms. With woodworking we use routers, but this is not a router, this is a milling machine. So at any rate, we're going to leave a little rise section in the center here. So this is probably going to go down another, and we have to have a shoulder high enough here that we can get a set screw into the shaft, so where our key is going to be. So for instance, if right here we had our key, then I'd want to have a set screw that comes down on top of that key and keys into both the that holds that key taut into my shaft on my motor. So so we'll probably slot this on our slotting head on the Acme mill, or I mean the Ajax mill, and which is a process that I have never done before. So that'll be a whole new different process. And we have to have enough shoulder here that I can get that set screw drilled and tapped. So I may have to get an extended bit and an extended tap to do that, because I don't think I'll be able to get, unless I just take a tap and just take it a 1/4 of a turn at a time. This is going to be really difficult to tap that hole. So at any rate, that's something that I'll have to think about as I go along. We will discuss that. So basically what's going to happen is this, these areas that are inside these slats will be milled down probably about 3/4 of an inch, so that I have a shoulder high enough to screw use a set screw to set into the arbor of the motor. So that's the intent there. I think that we've covered just about everything now. So what we'll do now is go to our next setup, and I'll bring you back when we're ready. Okay, so we've got our circle cut out. I didn't show you what I did here. I got this started before I brought you back. Forgot to tape it, so forgive me for that. Basically what we're doing is we're taking this whole thing down 1/4 of an inch and thinner, and then where we have all our fan blades, where they're going, that'll be a little bit raised. It'll be at this level, and then between the fan blades it'll be recessed even further, probably about another 1/2 inch. So basically what we're going to do is we're going to go ahead and take this all the way back to the edge, and then I'll clean up by each one of these brackets, and then we'll retighten it, and then we'll be ready to go with our next process, which we'll be setting up to make our little fins, our slot, our the holder for our fins. So we're going to go ahead and keep milling then, and you can join in on that. Okay, we're running at 700 RPMs. 5/8 cutter. Vacuum that out, and then we'll start another cut. So you may be wondering, why am I only cutting 5/8 at a time? But as much backlash as there is in this rotary table, I felt it was safer cutting smaller swaths at a time to get where I'm going than to try to take a big cut and be fighting the cut because of the table and the way that it's not a great table. It's good, but it's not fantastic. So my preference is to just take smaller cuts. When I tried doing some bigger cuts earlier, I ran into all sorts of problems. So we're just going to keep whittling at it until I get it to where I needed to go. And I don't want to take it off this and put it onto the Ajax. And well, I'd still have the same problem because it's the rotary table, it's not the machine. This machine's cutting just fine. It's just that I get too much movement in my my table. So that's the reason for taking such a small cut at a time, and we'll whittle at it until we get it done. So, like I was saying, due to the backlash in this table, the rotary table that I have, I've decided to just use a 5/8 cutter and cut this whole blank out. There'd be a lot faster way of doing this if I felt comfortable with my table, but the backlash is just really sad. So this is the way we're going to do it to prevent any mishaps or this grabbing into the table swirling or something like that. And that way we'll have a nicer job when I'm done instead of getting it all crunched up from some problem I have. So anyway, I'm going to let you all go, and I'll bring you back when I hit to my next process here. Okay, we're going to be starting our last cut. Okay, we're going to start our last cut. Yep. That was no good. Broke our part. Broke our cutter. A larger cutter. That's helping with preventing it from falling around. starting with a new setup now. We've gotten this, the base down to the dimension that I wanted it. This is the fin height that we have here. So now we're going to make the fin positions. Basically we're going to channel in on both sides where the fin is going to go, and that channel will be, well, it won't be a channel, it'll be a rise in this platform. The feature will rise above. We'll take down the rest of the metal around that feature at 6 places in the circumference, and then the fin will be welded into that rise, which will be about 1 inch and a little bit over 1 1/8 inch wide. So we'll use that to weld as a weldment for our fins that we're going to be putting on, or blades, whatever you want to call it. So basically we're setting up to make our very first cut, and what we'll do is we'll come back and forth until we get the cut to the depth I want, and I want to take it down 1/2 inch. So we're down 0.200, and we'll see if it cuts it nice at that, and we'll cut it right up to this edge here, and then we'll lower it and cut back out again, and until we get it down to depth. Then we'll move it and make our next cut. So let's go ahead and give it a shot and see what happens. That this 221 inside cut 2.2158. So basically I'm marking down where the cut comes to, where I'm stopping that cut, so that on all the following ones I'll be able to stop it at the same location. So that's that's why I stopped the machine. I wanted to mark that out. So now what we're going to do, we're going to turn the machine on again, and you might see that this is a radius in here. I've got a bull nose cutter, and so as I go down it'll have a radius. So at the bottom of the shoulder it will be radiused onto a flat. Once we get this all done, then we'll cut all the radiuses done and the weldments done. Then we'll clean this up with a flat one and keep the radius to this point, so that there's no sharp corners for the dust and from the system to stick to. That's the thought pattern at any rate. So let's go ahead and we'll cut the steel. I'm taking it down to 0.4000. Okay. So this edge is the inside edge of the weldment for the fence. So now we have to move the blade so that it cuts back this way and back. So we'll make our adjustment on that. And that we're going to set our DRO, what did I have it set at? 18125. 7, 3, 1, 2, 5. Let's go. Come on, baby. Right in there. There we go. Those tents are hard to hit. Takes a lot of finesse, and then once you tighten it, it sometimes moves it off. Okay, looks like we got it good. Okay, so now we're going to take her up to 0.20 and take her cut in. Okay. We'll reset our speed here. Okay, and we're ready for our cut. Let me just double check my dimensions. Okay, 18125, 18125, and start the machine. Next Okay, let me get this dimension down. 1.2996. Okay, so now we'll make every cut the same to this point on the high side. Now we can go ahead and plunge and start back. Okay, so now what we'll do is we'll turn this table 60 degrees and then we'll rinse and repeat. And this will be the weldment for the fin. So what we'll do is we'll cut into this part, make a channel 3/8 of an inch. It'll actually recess back into this part to that line there. And we'll weld that fin into that channel that we'll make in this weldment right here. The rest of this will be hollow down to each fin. So the base plate will be about a 1/2 inch thick. And then of course we'll have this weldment where each of the fins are and up from there. So let's go ahead, we'll unlock my table, spin it 360 degrees, not 360, but 60 degrees. And there's 6 of those. Oh boy, that one's tight. I'm going to have to get a driver in there or something. There we go. Okay. $20, $30. Uh-oh. Forgot about could have broke my tip off. 40, 50, and I'm going to have to get a light in there to see the 60. There we go. Go back a half a degree and lock her. Very good. Okay, so this is where our next cut will start, and we'll make our next fin.